Hi, my name is Patrick Heath, Senior Marketing Manager for Microchip's 16-bit microcontroller division and responsible for motor control. Today I would like to introduce you to our new dsPIC33CK low-voltage motor control development board. As the name implies, this board is designed to be used for rapid prototyping of a low-voltage BLDC or PMSM motor control application based on our latest 4th generation dsPIC33CK digital signal controller, or DSC. Let's start with why you would need a motor control development board. Some might ask, why can't you just use a breadboard, plug in the components, and just wire wrap the connections? Well, as it turns out, there are several reasons that this won't work. The first is that there is a lot of power flowing through the 6 MOSFETs shown here in the box. They need to be soldered to large copper pads on a printed circuit board in order to effectively conduct the heat away. Otherwise, they will pop or explode, and trust me, you don't want to be anywhere near them when this happens. Another reason is that motors inherently create a lot of electrical noise, and this noise will be conducted or induced into other signals and into the dsPIC motor controller itself, causing all sorts of issues. To avoid this, you need a real PCB with separate digital and analog power and ground planes and RC filters on the motor feedback signals. So let's say that you want to create an application which needs to spin a motor. Why should you buy this dsPIC33CK low voltage motor control board? Here are 7 good reasons for you to consider it. First of all, this board is very flexible. You can connect any 12 to 48 volt power supply. Also, the power supply section provides 3 regulated voltage outputs for the MOSFET gate drivers, the Hall sensors, and the dsPIC motor controller. You can power the board from any AC-DC power adapter with a positive tip style barrel connector, such as this 24 volt one that I bought on DigiKey. You can also use a lab benchtop power supply and connect it to the board. You just need to ensure that your power supply has enough current to run your motor at full speed. Second, this board supports a wide range of 3-phase motors, such as BLDC, PMSM, or IPM, which would be connected to the bottom right side of the board. If you don't have your own motor to start with, I recommend purchasing this 24 volt 1 amp BLDC Hurst motor from our Microchip Direct website, which we use for all of our out-of-the-box demos. We'll provide a link for the motor in the description of this video. Thirdly, the board supports a wide range of common motor control algorithms, starting with simple 6-step block commutation using 3 Hall sensors. Here, you can see the connector on the bottom of the board to hook up the 3 Hall signals plus power and ground. The board supports motors with optical encoders mounted on them. The connection for the encoder is located just to the right of the Hall sensor connector. However, the board also supports more advanced sensorless motor control algorithms such as back EMF voltage measurement using the voltage divider circuits, and field-oriented control, or FOC for short, using the current measurement op-amp circuits. Note that the dsPIC motor control DSC internally contains 3 very good op-amps, which can be used for measuring 2 motor phases and the overall motor current. Using these instead of external op-amps will provide a lower bill of materials cost, as well as a smaller PCB. Reason number 4 is that this board includes an advanced program and debug interface called PICKit Onboard version 4, shown here. Having this circuit on board saves money over purchasing a separate hardware programmer debugger, such as PICKit 4 or ICD4. With a USB cable connected to your PC, you can program the dsPIC digital signal controller and debug software using Microchip's free MPLAB X IDE. There's also a free software plugin to MPLAB X IDE called X2C Scope, which features a monitor that continuously reads variables from the target and displays the data as numeric values. The plugin also contains an oscilloscope-like GUI, including features like channel and trigger configuration for up to 8 channels and an offset and gain for each channel. For example, you can use X2C Scope to monitor the 3 motor phase currents and voltages in real time, change a control parameter, and immediately see the effect without having to recompile and program the flash on the dsPIC. This capability really saves a lot of time during the debug cycle. The 5th reason is that this board provides several expansion options to support different applications. On the bottom left side of the board are 2 connectors for adding microelectronica clickboards. There are nearly 1,000 different clickboards that you can select from to add different features, such as a display, a sensor, or a CAN or LIN transceiver. One interesting option for motor control is a new clickboard for the Microchip LX3302A rotary inductive sensor, which should be released soon. This inductive sensor can replace Hall sensors or other magnetic position encoders for motor position feedback. They provide much better accuracy and have very low temperature drift. Reason number 6 is the dsPIC33CK 256MP508 DSC itself. This 4th generation dsPIC device was designed expressly to spin motors. The CPU is optimized for real-time control loop execution. The motor control PWMs and the 12-bit 3.5 megasample per second A to D converter work together, minimizing CPU intervention to provide a very fast control loop response. Microchip provides the software to run all the different motor control algorithms I talked about for this device on this board. These are available either as a free download from our website or by using our free FOC GUI called MotorBench. Here you can see the board running dual shunt FOC with the Hurst motor, which is what the dsPIC is programmed to run out of the box. Finally, this board's a great deal. The cost is subsidized, making it Microchip's lowest priced motor control development board, and who doesn't like saving a lot of money? Thanks for watching this video. I hope that you found it useful. Please feel free to contact me or our closest Microchip sales office if you need help spinning your motors. Please visit microchip.com/motor anytime for more information on this board or on our dsPIC motor control devices and their development ecosystem.